Hey guys, in this video we're going to be solving systems of equations with three variables. To do this, I'm going to use a combination of substitution and elimination. So let's take a look at example 1. The first thing I'm going to do is isolate a variable from one of the equations. So I'm going to choose the first equation and solve for z. So now I have an equation for z in terms of x and y. So negative 4x minus 5y minus 18 represents z. Next, I'm going to take that expression, negative 4x minus 5y minus 18, and substitute it into the other two equations in place of z, and simplify to create a subsystem of only two variables. Next, you're going to solve the subsystem using whatever your preferred algebraic method is. Now, I noticed that the y variables have opposite coefficients, so I'm going to use the elimination method and add these two equations together to eliminate y so that I can solve for x. Next, I'll use back substitution to solve for the other variables. So I'll substitute the value of negative 4 in place of x into whichever one of these equations I choose, and then I'll substitute the values for x and y into whichever equation I choose from the original system. And the last thing I'm going to need to do is verify my solution by plugging in x, y, and z back into each of the original three equations of the system and verify that they're all true. So our solution is the ordered triple negative 4, 0, negative 2. And our system is consistent and independent. Now my preference for solving systems of equations is typically to use substitution whenever I have whole numbers and whenever it's convenient. So in this case, I actually do think substitution would be really easy because we have a single x here, so it would be very easy to isolate x from this equation. We have a single z here, so it would be very easy to isolate z from that third equation. However, I already showed you an example using the substitution method, so I'm going to use the elimination method instead. The key with using the elimination method with three variable systems is that you want to pick a variable to eliminate and eliminate it twice. So first I'll decide which variable I want to eliminate. And I've chosen to eliminate the variable z because I'll only need to manipulate one equation before combining the second and third equation together. So to eliminate z, I'm going to combine equations 1 and 2 together, and I'm also going to combine equations 2 and 3 together after multiplying equation 3 by negative 3. Now in combining equations 1 and 2 together, we actually eliminated the y and the z at the same time, which allowed us to solve for the value of x. So that's going to kind of shorten this process a little bit for us, because we'll be able to substitute 3 in place of x in this equation once we have eliminated the z. And now we'll use back substitution and plug in those values to whichever one of the original three equations we choose to solve for that variable that we eliminated first. So after we verify our solution, we know that our system is consistent and independent with an ordered triple solution of 3, negative 1, 2. Let me know if you have any questions. Thanks for watching.